Okay, for limits, day 2 of limits, we're going to be looking at limits more algebraically rather than graphically like we were looking at on day 1. The first example there talks about the limit as x approaches b of f of x plus g of x. That is equivalent to the limit of f of x as x approaches b plus the limit of g of x as x approaches b. So that's kind of using our property number 1 up above. So what I would look at is, what is the limit of f of x as x approaches b? It's 7. Plus, what's the limit of g of x as x approaches b? It's -3. So I would just do 7 plus -3 and get 4. Multiplication follows the same way. This is the limit of f of x as x approaches b times the limit of g of x as x approaches b. So this is 7 times -3, or -21. A constant you can always pull out in front. So this could be 4 limit of g of x as x approaches b. So it's 4 times a -3, which is a -12. And then division, limit of f of x as x approaches b divided by the limit of g of x as x approaches b. So this is 7 over -3, which is -7/3. First step to evaluating a limit is always to plug it in, or substitution. So, if I'm doing the limit as x approaches 2 of 2x, I'm just going to plug in x is 2. So if x is approaching 2, we're going to plug in that x is 2. For the next one, limit of a constant is the constant. So that's something you need to know. Limit of a constant is the constant. And you can always think of limits graphically. So what I would want to think of is this is like the equation right here. Like this would be like a y equals 4. If you think of y equals 4, 1, 2, 3, 4, then as you approach 6, coming from the left, coming from the right, either way, you're still approaching a y value of 4. You're actually at a y value of 4. But limit just means what are you approaching. Okay, so here's another plug it in. 3 times 1 minus 1. That is 3 minus 1, or 2. Here we plug in 0 over 0 minus 3. 0 over -3 is 0. Remember, 0 in the numerator is 0. 0 in the denominator is undefined. If we get 0 over 0, that's something called the indeterminable form, which we will look at in a minute. E to the 0 is 1, right? Anything to the 0 power is 1. 2 minus 1 over 2 minus 2. 1 over 0, which limits means does not exist. If you get something undefined, that means the limit does not exist as x approaches that 2. And this is ln1. ln1 is 0. We just reviewed natural logs. But just a reminder, the reason that is because this is a base of e. So it's saying e to what power gives you 1. E to the 0 gives you 1. So that's why the answer is 0. Okay, if you get the indeterminable form, 0 over 0, infinity over infinity, which we'll see in coming days, or 0 times infinity. Those are indeterminable forms. That means you must do something else. So for today, what we'd be trying is factor cancel, plug it in, or rationalize cancel, plug it in. Okay, limit as x approaches 2. Now, talking about proper notation, you do have to write limit every time until you do the limit. So here I'm doing limit as x approaches 2. I'm going to factor. The reason I'm doing that automatically is I already know that if I plug 2 in, let's see, 2 squared is 4, minus 6 times 2 is 12, plus 8 over 4 minus 4. So yeah, I would get negative 8 plus 8, which is 0, over 0, indeterminable form. So since I get the indeterminable form, I have to do the factor cancel, plug it in. Now, you can always factor cancel. So if you notice something will factor and cancel, you can always go to factor cancel. Now I'm going to plug in 2 minus 4 over 2 plus 2, plugging 2 in for x. I get negative 2 over 4, or negative 1/2. Limit as x approaches negative 3. I'm going to factor 15. I want to think 5 and 3. I just have to determine the order. So I think if we do 5 here, 3 here, think about it. Outers would give you a 6x. Inners would give you a 5x. Those will add to an 11x if we make those both positive. Bring the x plus 3 from the bottom. Just bringing that over. Those cancel. And now we can plug in. So notice when I'm plugging in, that's when I'm actually doing the limit. I do not need to write limit anymore. But before then, I do need to write limit. So when you're plugging in, you don't have to write limit anymore. Okay, now the next one, if I plug in, I'm going to get radical 1. Square root of 1 is 1. 1 minus 1, 0 over 0. So that's the indeterminable form. So since I get the indeterminable form, what I have to do is multiply top and bottom by the conjugate of that radical. So limit as x approaches 0. Here I multiply through. Firsts give me x plus 1. Outers and inners are going to cancel out. Maybe for the sake of your notes here, I'll write it. But we're basically just going to get plus that radical x plus 1 and then minus that radical x plus 1. And then lasts will give me minus 1. Now, what we do, so wherever we have the two radicals, we're going to FOIL through. Wherever we have the radical with the non-radical, I'm purposely not going to distribute that. So these cancel. 1 minus 1 cancels. So I have the limit. I just have x on the top, or limit as x approaches 0. I have x on the top, x parentheses square root of x plus 1 plus 1. These x's can then cancel. So now if I plug in, I get 1 over 2. Square root of 1 is 1, plus 1 is 2 on the bottom. For the next one, I'll kind of give you a minute here because I'm going to have to erase Give myself some more room here. Okay, so we're going to have to multiply top and bottom again by the conjugate, just to kind of show if I plugged in, I'd get 0 over 0, right? Just checking that. So that's why then the only thing I can do is multiply by the conjugate. So limit as x approaches -3. On the top where I have the radical with the non-radical, I'm going to purposely leave that. Not distributed. On the bottom where I have the radical with the radical, that's where I'm going to distribute. Outers, inners are going to cancel. Lasts give me -4. Okay, got x plus 3 times square root of x plus 7 plus 2 over, now on the bottom I have x plus 3. So that's exactly why I don't cancel. Note in the last one, the x's canceled on top and bottom. Here, the x plus 3's are going to cancel on top and bottom. So that's why I'm leaving the top, in this case, not distributed. All right, that's square root of 4 plus 2. 2 plus 2 is 4. Now, when you have a cubic that's not factorable, right? The only way in the past you've learned to factor this is maybe a 2 by 2 grouping. But a 2 by 2 grouping is not going to get us anywhere. We're not going to get a common factor that we can pull out. So I have to do limit as x approaches 4. I'm going to do synthetic division. So 2x cubed, -5x squared, -11x, -4. Bring down the 2, multiply, add going down, multiply, add going down. So doing my synthetic division, it divides in evenly. So I'm going to do the limit as x approaches 4 of, remember this last thing here is your remainder. So the 1 is your constant, the 3 is the coefficient of the x, the 2 is the coefficient of the x squared. So it's 2x squared plus 3x plus 1. So when I divide that, that's what I get. And now I can do the limit as x approaches 4 by plugging in. So let's see, 4 squared, 16, 16 times 2, 32, plus 12, plus 1, which is 45. Again, if we plugged in here, we'd get 0 over 0, indeterminable form. So just to review, to factor the top is the difference of 2 cubes. So that's where we do SOAP, a minus b, a squared, plus ab, plus b squared. So if you have an a cubed minus a b cubed, a minus b, a squared, plus ab, plus b squared. So remember, SOAP is standing for same sign as the original, then opposite, then the third is always positive. All right, so now these cancel. I plug in. I get 4 plus 4 plus 4, 12. Okay, so the next one gives me a piecewise function. I I do not have to graph this. All I have to do is think of, okay, what's the limit of the f of x function as x approaches 1 from the left? Well, 1 from the left would be here, right? Less than or equal to 1 is to the left of 1. So I would plug in to that x minus 2 and do 1 minus 2, negative 1. If I want to do the limit of f of x as x approaches 1 from the right, now I'm looking here, greater than 1. So into the 3x minus 5, I want to plug in 1, I get negative 2. So from the left, from the right are not the same y values, which means the limit of f of x as x approaches 1 does not exist, right? For the limit to exist from the left, from the right, we have to be approaching the same y values. Basically, there'd be a jump in the graph there. All right, last thing is right and left-handed limits algebraically. So what I would need to look at, 1 over x minus 3, I should realize that that has a vertical asymptote. I have a vertical asymptote at x equals 3, right? So what I have to determine is, we know to the left and the right of a vertical asymptote, that's where a graph either kind of shoots down to negative infinity or up to positive infinity. So what I want to do is make a number line. 1, x minus 3. So let's see, 1 is always positive. X minus 3. So I want to think of plugging in something to the left of 3, but just to the left. So let's say 2.999. If I plug 2.999 in down here, I want to think, is that going to be positive or negative? Well, it would be negative, right? And then a positive divided by a negative is negative. If I put something to the right here, just to the right, 3.0001, that will be positive. Positive divided by a positive is positive. So as I approach 3 from the right, we're going to positive infinity. From the left, it would be negative infinity. So from the left, I could use the same work to say 3 from the left would be negative infinity. Based on, kind of coming back over here. If I'm to the left of 3, I have that. Okay, now if there's a hole, which I would only know in this one, what I have to do is I have to factor, right? Because I always have to see if I can factor cancel. So I want plus 3 minus 2, so it multiplies to negative 6, adds to positive 1, cancel, and then you can just plug in. So if there is a hole, then factor, cancel, plug it in. All right, and last one. So this one, again, so I can't factor cancel. I do know there would be a vertical asymptote at 3, and that's because 3 is what makes the fraction undefined. It's what makes a 0 in the denominator. So what I need to do is make a number line. 4x, 27 minus x cubed. I need to take a number, again, slightly to the left of 3, 2.999. Okay, if I put that in here, it's going to be positive. If I put that in here, it will also be positive, right? Because that'll be slightly low. So this is overall positive, or I could think of going to positive infinity. If I take 3.0001 in here, that's positive. In here, that'll be negative, which then makes this negative infinity. So if I'm approaching 3 from the right, going to the right, it's negative infinity over here to the right of 3. Okay, so that's it for limits algebraically. Tomorrow we'll be looking at trig limits. Or trig limits will be our day 3, I should